All right. Hey, good morning, everybody. Um, Welcome to our Friday class. Okay. Um, let's uh, talk real briefly about, I guess you could say, what's the plan for today. Um, Number one, I want to make sure that we are okay with assignment 25. If I need to continue going over the lecture notes, we'll do that. If there are questions over the homework from that assignment, we can go over those questions. Um, I want to make sure that we're good with assignment 25. Um, I don't have a quiz for today. Um, so what I'm thinking about doing is we may um, uh, I'll either have some sort of over the weekend quiz, or we'll do some sort of quiz on Monday to make up for the quiz from this week. Um, in terms of next week, um, week 15, um, so the next assignment is assignment 26, determinants and Cramer's rule. All right, I have all the notes and lecture videos up for that assignment. Um, it's a nice little, Cramer's rule is a nice little uh, method that you can use to solve systems of equations. It's just another method that's available to us. Um, and I know that in the syllabus, um, we have another assignment. Um, I guess that would be assignment 27, the binomial theorem. Um, I don't know if we're going to do the binomial theorem or not. Um, at this point, I'm thinking that we're not going to. So here's what's going to happen next week. On Monday, we'll definitely be going over any questions that you have from assignment 26, determinants of Cramer's rule. Definitely on Friday of next week, we'll just review. Um, Possibly on Wednesday as well. We'll either review on Wednesday or we'll talk about the binomial theorem on Wednesday. I haven't decided yet. But let me talk about the review real quick. Here's the way I do reviews. I let you ask the questions. You have the review in front of you. You have the final exam review. You have review for Unit 4. You have all of your exams, all of your homework. The final exam is comprehensive, meaning that anything that we've covered this semester can be on the exam. Anything that we've covered this whole entire semester can be on the exam. Does that mean everything that we covered be on this semester? No. We don't have the time for that. But anything that we've covered this entire semester may be on the exam. So here's the way I do the reviews. I let you ask the questions. What do you want to talk about? Is it from the review? Is it from an exam? Is it from some homework topic? Do you have questions from the review? Bring them to the table and we'll talk about them. I am not going to sit up here and just start at problem number one on the review and work my way through it. I don't do that. I let you ask the questions. So if you don't have any questions, then I guess we're just going to sit here and twiddle our thumbs. So make sure that you spend some time looking at that review, reviewing previous material, develop a list of questions, things that you want to go over, and that will make a good use of our time on Friday and possibly on Wednesday of next week. All right, so I think that's all I have to say in terms of announcements. Reminder, our final exam is okay. I've said that says Wednesday. What does the syllabus say?
Mr. Clopton,
Yes, sir.
will the final exam be the same, same length as all the other exams?
So, that's a good question. Um, all right, so um, approximately yes. So your previous exams have been broken up into two parts, um, so that I could basically give you a good exam uh, for that material that we've covered. Um, so in terms of length, I mean that's a hard question to say because some of the problems, um, I mean I would say yes, give or take. Some problems take a little bit of time, some problems take a little bit longer amount of time. So how many questions are in a final exam? I don't exactly know. I always change it up every semester. Um, but you can expect, you know, to spend, um, you know, the amount of time that it has taken you in the past to do those two exams, the exam one, exam two, part day and part one, day one and day two, um, is the same amount of time that you're going to need for um, um, this exam. I have a quick, well, I I had in my head that the final exam was going to be on Monday, but the syllabus says Wednesday. Um, so I guess it's on Monday, or excuse me, I guess it's on Wednesday. Um,
Will we have class on Monday then?
no. No, we will not have class on Monday. Um, I gotta think about that. I got distracted with a thought. Answer is no, we will not have class on Monday. So next week, Monday, Wednesday, Friday, those are our final scheduled meetings for regular class, and then um, the final exam um, for this course will be given on Wednesday, December 15th from 8 to 10. All right. questions. Do we have any questions over assignment 20, 25?
Can you do number 2?
Yes, let's look at number 2. Let's get things warm up here. Okay. All right, assignment 25, problem number 2. All right, we have a small television. Has a picture with a diagonal that measures 10 inches. So when we talk about the diagonal, we're talking about that dimension right there. The diagonal is equal to 10 inches. And a viewing area of 48 square inches. So the question that we're asked is, what's the length and what's the width? And we know that the area of this TV is equal to 48 square inches. And we know that area is equal to length times width. So that means that 48 is equal to LW. So there's one equation. And to get the diagonal, so I know these questions are given to you, but we're just going to spend some time to derive them. The diagonal, since this is a right triangle, we're going to use the fact that a squared plus b squared is equal to c squared. This is, of course, what do we call this equation? Anybody? Any know the name of this equation? Pythagorean theorem? That familiar? A squared plus b squared equals c squared. So that's for a right triangle, right? Well, don't we have a right triangle right here? That would mean that L squared plus W squared would be equal to 10 squared. Or L squared plus W squared is equal to 100. So these two equations are the two equations that we're going to use to derive, to figure out what is the length and width of this television screen. So here's our system. L squared plus W squared is equal to 100, and LW is equal to 48. So we have to go through and solve this system. Did anybody solve this problem? Here's what I would do. This is very much like the application problem that we looked at in our notes. Um, back in our notes, we looked at problem number, um, so we did problem number 5 in our notes. I've had to redo this because I had my 9 o'clock or 10 o'clock class come in. But in our 9 o'clock class, we did example 5, and if you remember, back in example 5, um, when we had that x times y was equal to 36, and 2x plus 3y, actually that was x times y was equal to the 54, and 2x plus 3y is equal to the 36. What we did was we solved for x. We said that x was equal to 54 over y, and we took that and we plugged that x in right there. We're going to do the same thing in this problem. We're going to take a look at equation 2. That's what I've labeled it. LW is equal to 48, which then means that you can solve for L or W. It doesn't matter which one you solve for. L becomes 48 over W. And so what do we do with this? What do we do with this little statement that says L is equal to 48 over W? We substitute it into the other equation. So what is my other equation? My other equation is equation 1. And so what do? We're going to plug this in for our L. And so this is going to give us the following. 48 over W squared plus W squared is equal to 100. All right. Looks like we got to do some work. All right, so what's 48 squared? Forty-eight times 48. Hello? Anybody? Yes, I'm asking you to speak into the microphone. Somebody answer my question. What is 48 squared?
$2,304.
Thank you. See, I like to know that I'm not the only one here. Okay, now, here's my next question. What do you not like about this equation?
The fraction,
How do you get rid of a fraction?
you multiply it
By what?
by the denominator.
What is the least common denominator?
W squared.
Yes. W squared. So we're going to multiply everything in here by W squared. Alright, so that's going to give us what? The 2,304 plus w to the fourth is equal to 100 w squared. Now, hopefully this works out well. We're about to find out. I would set this equal to 0. Now, at this point, what we have is we have a quadratic type equation. We have a quadratic type equation. So, how do we solve quadratic type equations? We use what's called a U substitution. So we're going to let U be equal to W squared, which then means that U squared is going to be equal to W to the fourth. And so using this substitution, we now can say that we have U squared minus 100U plus 2,304 is equal to 0. Now, we need to solve this guy. So, there's two ways to do this. You could use the quadratic formula, or we could seek to answer the question, what are the factors of 2,304 that sum up to 10? Excuse me, not 10, but 100. Now, I'm going to sit here, I don't know this off the top of my head, so I'm going to sit here with my calculator and I'm going to work to figure it out. You do the same thing, and if somebody tells me that they have an answer, let's present the answer to, present your answer to me, but let's do some work. So I'm going to just sit here and work to figure this out. I got it. Do you? So what I did was, I was taking my calculator right here, and I was doing all sorts of, let's take 2,304 and let's divide it by 4. Let's take 2,304, divide it by, 48. And I was doing all this work, and I was looking for an answer such that the 4 plus whatever my answer was added up to 100. Well, I tried a bunch of multiples of 4. I wasn't really getting anywhere. Then I tried 2,304 divided by 6. And that ended up being a nice whole number. So then I said, oh, well, let's try multiples of 6. And I went all the way up to 2,304 divided by 36. And that came out to be 64. And guess what? 36 plus 64 is equal to 100. So what's the answer to our question? 36 comma 64 equals, when you add them together, equals 100. That's the kind of work that you got to be able to do in a problem like this. You have to be able to sit here and do some calculation work and, try things out, realize that they don't work, try it again. Gotta keep on working on stuff. Alright, so what do we get? Here, this becomes u plus 36, u minus 36, because that's a negative 100. And then u minus 64 equals 0, which then means that u is equal to 36, u is equal to 64. Now, remember what was u? U is w squared. So we have that w squared is equal to 36, w squared is equal to 64. Now, how do you solve these equations? Well, we don't like the squared, so we got to square root both sides. What do we include when we square root both sides? A plus or minus notation. And this means that w is equal to plus or minus 8. Excuse me, not 8, but plus or minus 6. And w is equal to plus or minus 8. Now let's think about the context of this problem. The context of this problem says that we're talking about dimensions, length and width. So that means that we can come over here and we can omit the negative answers. So that means we have w is equal to 6, comma, w is equal to 8. Now, using the fact that w is equal to 6 or w is equal to 8, now we need to go through and find, what's the other dimension? Length. Now, take a look back over here at our second equation. Length times width is equal to 48. Length times width is equal to 48. Now, I know that 6 times 8 is 48, so that means for w equal to 6, the length is equal to 8, and for w is equal to 8, that means the length is equal to 6. Now, only one of these solutions is correct. What are we talking about? We're talking about a TV, right? Here's my picture of a TV. Now, most TVs these days are set up in this horizontal position where the length is longer than the width or the height of the TV, right? The length is the longer dimension. So come over here, which one of these two answers makes sense? Here this says the width is 6, the length is 8, so that would be a TV that looks like this. Here the width is 8, the length is 6, that would be a TV that looks like this. Now, I'm sure that you've seen some people like their computer screen set up like this, in a vertical fashion. I don't, but I have a coworker that loves to have his TV screen set up like this, or a computer screen set up like this. But when we're talking about TVs, movies, they all are in this format. So what is our answer to this question? The length is equal to 8 inches and the width is equal to 6 inches. That is a very, very small television. Well, I mean, I guess that's kind of like my iPad. Kind of like my iPad. Maybe it's more like an iPad mini. Excuse me. Alright, so to the person that asked that question, does that make sense? Alright, right now I only have one school connected. Is that Post or Plains? I can never remember.
It's Plains.
How are y'all doing, Plains?
We're good.
We're good. Alright, looks like Lorenzo got connected again. Alright, Plains, do we have any questions over assignment 25?
Not right now.
Here's my next question. Did y'all see my announcements about the completed instructor notes?
Yes, sir.
Did you take a look at those completed notes?
Yes, sir. We're working on them.
Does it make sense? Do we need to go over anything from those notes?
No, sir.
Sudan, I see that y'all are reconnected. Let's do.
Yes, sir.
All right. Hey, let's do a problem from the homework. I just feel like I need to do something to help y'all out. So let's do a problem from the homework. Somebody, it doesn't matter which one you pick. Anything from problems, I guess, 1 through 12. Let's pick a problem. We've already done 2. Let's pick another problem. Anything from the homework.
Can we do number 11?
Number 11. That's a good one. Number 11. We want to graph and shade the system. So equation 1 is x plus 2 quantity squared plus a y minus 3 quantity squared is less than or equal to 25. And the second equation is x plus 2 squared plus a y minus 3 squared is greater than 9. Now, here's my first question to you. Equation 1 and equation 2. These are equations of what? What are these equations of? Bless you.
a circle?
They're equations of circles. They're equations of circles. So recall that for x minus h quantity squared plus y minus k quantity squared equals r squared, that the center is hk and the radius is r. So, my question to you is this. For equation 1, which is the equation of the circle, what is the center and what is the radius?
The center would be -2, 3, and the radius would be 5.
Good. You're exactly right. Excuse me. If you remember, I said one thing to remember is just what's the opposite of the positive 2? What's the opposite of -3? That will give you your center. Square root of 25 is 5. All right. Now, for equation 2, same question. What is the center and what is the radius?
The center is -2, 3, and the radius is 3.
So, the nice thing about this is that both these circles have the same center. Alright, so we're going to graph and shade. Now, a couple of thoughts that I'm going to be thinking about as I'm doing this. Because of the or equal to, we're going to use a solid line. And because it's strictly greater than, no, or equal to, we're going to use a dotted line. I mean, it's really dotted line. Solid circle and dotted circle. Alright, here we go. First of all, I'm going to graph my coordinate plane. I think that will give me enough room. Probably need to go up a little bit. Alright, first circle, we're going to graph, because I like to do different colors. We'll do this first circle in blue. The center is at -2, 3, so we need to go to -2, up 3. So -2, up 1, 2, 3. There's our center. And the radius is 5. So I need to go up 5. 1, 2, 3, 4, 5. To the right 5. 1, 2, 3, 4, 5. Down 5. 1, 2, 3, 4, 5. And then to the left 5. 1, 2, 3, 4, 5. And we're going to graph this circle. Alright, again, as I said before, this is not art class. Alright. Not a great circle, but it's going to get the job done. Now, this says less than 25. Now, that means that we're going to shade inside the circle. Now, here's a quick way to test this. Pick a test value that's in the circle. Well, it just so happens that 0, 0 is in the circle. So if I come back up here and test 0, 0, 0 plus 2 is 2, 2 squared is 4, 0 minus 3 is -3, -3 squared is 9, 4 plus 9 is 13, that's less than 25, check. So, Now, I'm not going to shade it just yet because we want to shade the region that is common to both circles. So I just put my little arrows in here to tell me that I shade inside. Then the second circle, we'll graph it red. The nice thing is it's the same center. So -2, 3. And the radius is 3, so we need to go up 3, 1, 2, 3. To the left, to the right 3, 1, 2, 3. Down 3. To the right 3, 1, 2, 3. And we're going to graph a dotted circle. Again, what did I say? This is not art class. Now, this says to greater than 9. So where are we going to shade? Well, greater than 9 means we're going to shade outside the circle. A quick way to verify this is to again use a test point. I'm going to use test point 0, 0 again. Now, since 0, 0 is not in my circle, I should get a false statement. 0 plus 2 is 2, squared is 4. Hold on. Maybe 0, 0 is in a circle. No, it can't be. Oh, what am I thinking? 0, 0 is outside the circle. Yeah, it's outside the circle. So, if I plug in 0, 0, I should get a true statement. Sorry, I was thinking a false statement. That's going to be 4. That's going to be 9. 4 plus 9 is 13. That's greater than 9. Check. So what's the common shaded region? What's going to be the region in the middle? The region in the middle is the set of points that satisfy both of these inequalities. There is our solution to the system. So my question to you, does that make sense?
Yes, sir.
Awesome.
What if they're both greater than?
Are you looking at a particular example?
No, I was just wondering.
So if they were both greater than, that's a good question. If they were both greater than, let's have two circles like that, right? If they're both greater than, let's say that this is greater than and that's greater than, you have to shade the region that is common to both of them, right? Now, what's greater than this big circle? Everything out here, right? Well, if I just ignored this big circle and shaded this region outside every circle, it would be everything out here. So the common region would be just basically everything outside the big circle. Does that make sense?
Yes, sir. Thank you.
Now, here's an interesting question. What if you had a system where, again, you graphed two circles, and the first circle was greater than, the second circle was less than, so you would shade inside this region and then shade outside this region. What's the overlapping area?
You would have no solution?
Yes, exactly right. If you had a big circle that you would have everything's greater than, shading out here, and a smaller circle inside of it where everything was shaded inside. There's no overlapping region. There would be no solution. Does that make sense?
Yes, sir.
Alright, what else can we look at? We got 6 minutes.
Can we do 3?
3. Now, when I look at this system, so let's say I'm looking at here at equation 2. And let's just say I want to substitute into equation 2. Alright, if I'm going to substitute into equation 2, that means I need to get x by itself up here in equation 1. Trying to get x by itself up here in equation 1 does not look good to me. Because I'd have to move everything over it, and then I'd have to square root both sides. And I just don't want to deal with that. Trying to get y by itself, trying to solve for y, substitute into y, means I'd have to get this y up here by itself, but then I'd be substituting into a y, and then I'd be having, this would be in terms of x squared and y squared. Plug it in here, that's not going to do me any good. So we need to come up with another way to solve this. And my suggestion doesn't mean that this is the best suggestion or a great suggestion. My suggestion is to take equation 2 and solve for y. Quite honestly, that's the easiest variable to get by itself. Y is going to be equal to a negative 2x minus 1. And then I would plug that into, actually, that's not going to help me. Why does that not help me? Because if I plug this in up here, I still have things in terms of x's and y. So scratch that idea. Scratch that idea. Let's go back to equation 2. Solve for x. Solve for x. So we have 2x plus y is equal to negative 1. So that means 2x is equal to negative y minus 1. That means x is equal to negative y minus 1 all over 2. Now, I think this is going to work. Because now, if I take this and substitute it in for
Your
x
conference
up
is
here,
scheduled to end in 2 minutes.
here's what you get. We're going to have negative y minus 1 over 2 quantity squared plus y squared plus 3y is equal to 22. Alright, so let's do some math. So we need to take negative y minus 1 and square it. That's the same thing as negative y minus 1 times a negative y minus 1. So it's going to give me y squared. Negative y times a negative 1 is a positive 1y. So that's going to give me plus 2y plus 1 all over 4 plus y squared plus 3y is equal to 22. Now, what do you not like about this equation?
The fraction.
How do you get rid of the fraction?
You multiply by 4.
Good. So, in my closing arguments here, y squared plus 2y plus 1 plus a 4y squared plus a 12y plus equals 88. Solve that for y.
Your conference is now over. Goodbye.
5y squared plus a 14y minus 87 equals 0. Solve this. All right. Five times 87 factors of a negative 435 that sum to a positive 14. I'll have to come back to that later.